In this video, we are to solve this boundary value problem by method of separable function. We have that u, that x to be equal to 4 that u that y, and the boundary value here is 0, y to be equal to 8 exponential minus 3y. So to start with, we are going to let u to be equal to xy. Let u to be equal to xy. So let's examine this that we have here, this equation we have here. We have u differentiating with respect to x here, so we are going to have this to be x prime of y because it's differentiating with respect to y. Remember, u is now x y. Now we're going to have here to be 4x y prime because it's differentiating with respect to y. So we are going to collect like terms from here. That means we are going to have x prime divided by 4x to be equal to y prime divided by y. We have that to be that. So we are going to equate this with p here. The both left hand side and the right hand side will be equated with p. Now let's deal with the left hand side first, which we have it to be x prime divided by 4x to be equal to p. So this is going to give rise to, x prime stand for dx over dx. So this is going to be dx divided by 4x dx, which is equal to p. So we are going to bring 4 dx to the right hand side, and we'll be left with x here, which will be 1 over x dx to be equal to 4p dx. So at this point, we are going to integrate both sides. 1 over x dx to be equal to integral of 4p dx. So if we integrate both sides, we are going to have integral of 1 over x to be ln x to be equal to integral of 4p dx. We are going to have 4p x plus a constant c. Let's call it constant c. So now we are going to take the exponent of both sides. Let's take exponent of both sides. And if we take exponent of both sides, we're going to have exponent of ln x to be equal to exponent of 4px, and then exponent of c. I'm going to have it to be this way: exponent of 4px and exponent of c. Remember, putting up this together was going to have 4px plus c, so we can as well write it this way. So now exponential of ln is going to turn to x. Exponential ln is equal to 1, so x is going to be equal to, and exponential of c, a constant, let's change it to another constant, say constant b. So we're going to have constant a rather, a exponential 4px. So let's call this our answer 1. Now let's look at the second part here, the right hand side. Let's consider the right hand side. From the right hand side, we have y prime over y to be equal to p. So what can we make out of this? So similarly to what we did earlier, y prime is equal to dy over dy. So putting that here, we are going to have it to be dy divided by y dy to be equal to p. So we are going to have it to be 1 over y dy to be equal to p dy. Let's have to p dy. So integrating both sides now, we have integral of 1 over y dy to be equal to integral of p dy. So integrating 1 over y, we are going to have ln y to be equal to, integrating p dy, we are going to have it to be py plus constant, let's call this time constant d. Let's call it constant d. Let's take the exponent of both sides. So if we take the exponential of both sides, we're going to have exponent of ln y to be equal to exponent of py multiplying exponent of d. So exponent of ln is going to give you y here, which will be equal to, let's call this exponential d a different name, which is constant b exponential py, and this is our answer 2. So we are going to merge these two answers. Remember a1 and a2, we are going to merge them. Remember we said u should be equal to xy. You say u to be equal to xy. So this is going to be x here and this is y here. So x, we have it to be a exponential 4px, then we have p exponential py. So let's add this together. We're going to have ab exponential into 4px plus py. So product of two constants will give rise to another constant. Let's call this constant e. So we have constant e exponential, p is common here, let's put it outside. We have 4x plus y. So let's call this star. So let's look at star and compare it with what we have here with our boundary value problem, the condition there. So we have 8 exponential minus 3y at u into 0 comma y. So let's look at what we have here. Here now we have u to be equal to e exponential p into 4x plus y. So that means at x equal to 0, we have exponential, e exponential p into, this is 0 here, and this is going to give you y. From the boundary value condition that we have here, this is only possible if e is equal to 8 and if p is equal to minus 3. So this is possible if e is equal to 8 and p is equal to minus 3, then u x comma y will now be equal to 8 exponential minus 3 into 4x plus y, and this is going to be 8 exponential minus 12x minus 3y. So this is the required solution. This is the required solution for this boundary value problem using method of separable function. Please like this video, subscribe to this YouTube channel, and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.